Okay, I want to introduce the concept of a tangent line here. It's a pretty easy concept. But a tangent line is a line that shares the same point as a curve and has the same slope at that point. So I've got two graphs here. The first one just shows a curve in red and then a green line next to it at a point. This green line would be the tangent line at that point. So what happens is if you were to take a hard surface and press it up against the curve, it would be the point where it touches it, and it would be pointing in the same direction that the point is, or the curve is moving at that time. The second one here shows a little bit better. It's got a curve and it's got several points highlighted and tangent lines attached to them. So we just talked about, when we talked about the derivative, that the slope is not the same everywhere along a curve. It changes. Okay, the rate of change is different from point to point. So when I take a hard surface and press it against the curve, if I start to kind of tilt that surface, it's going to run to a different point. So each one of these points has a tangent line attached to it because it's moving at a different rate at that time. You can almost think about it as the curve being a roller coaster or some type of track. And imagine that things are just going to keep moving no matter what. So if we're going along the track and the track disappears somewhere, the whatever's traveling, the train or whatever, doesn't keep turning. It's just going to go in the direction it was facing at that time. So even if the curve was turning, if the track disappeared or the curve disappeared at some point, the train would just go off in a straight line, which we call that a tangent line. Okay, so we're going to talk about how to make that line, and we're going to do that. So given what I've just told you, we're going to create a tangent line for a given x value. So one thing we need whenever we make a line, because that's all we're doing, we're making a line, we need a point, okay, on the function, and we need a slope on the function, which we can find from its derivative. Okay, and if we have that point and slope, we can plug it into the point slope formula we learned a while back. Y minus y sub 0 minus m times x minus x sub 0, the point slope formula. And we can rearrange that into slope-intercept y equals mx plus b to make our life a little bit easier if we did want to graph it. So let's see here. I've got a couple of examples, and they're functions we've already worked with. So the function that I'm given in the first one is f of x equals x squared. Now think back a moment, because we just found the derivative of that, and it was f prime equals 2x. So when we want to find tangent line, we need a point. Now they're telling me that x is going to be negative 2. That's what they want me to work at, or work with. So I'm going to say that the y is going to be f of negative 2, which will be 4. So when I square negative 2, it'll be 4. So I've got the point xy is going to be negative 2, 4. And I'm going to use the derivative to find the slope. So m will be f prime of negative 2. So that would be 2 times negative 2 would be negative 4. So m equals negative 4. So I've got a point and I've got a slope. So I'm going to use my point slope formula. Y minus y naught here will be minus 4. Okay, and then equals the slope of negative 4 times x minus the x value of the coordinate, so x minus negative 2. So we'll clean this up a little bit. So we'll have y minus, we'll distribute the negative 4 on the other side. We'll have y minus 4 equals negative 4x minus minus minus, so that'll be minus 8. And then if we pull the negative 4 from the right side over, we'll have y equals negative 4x minus 4. That's going to be our tangent line. Okay, I'm going to pause the video and pull something up real quick so you can see it. Okay, so we have the function x squared that goes through the point -2, 4. And we decided the slope was -4 and the tangent line was y equals -4x minus 4. So just to make sure you understand that, here's the graph. So the red line here, the parabola, is the x squared graph. And then over here is the point -2 for x and +4 for y. And the blue line is the tangent line that goes through there, y equals -4x minus 4. So you see it's just kind of barely touching there. So I'm going to zoom out so you can see how it's kind of just leaned up against the function right there at that point. Okay, so that looks really good. It's telling us the slope right then is -4. So if we were coming down this track and the track normally curves, but if something happened to divert from that, we'd probably go in a straight line, which would go off in that tangent. Okay, let's do the next one down here. So the next one is y equals square root of x. So what did we do? We know that y equals square root of x, and just a moment ago we found the derivative, which would be y prime equals 1 over 2 square roots of x. Well, from the first one we can get the slope by, the point by plugging x in. So if we plug in x being 9, the square root of 9 is 3. So we have an xy point of 9, 3. Let's just make sure we say that. That is our xy. And then the slope will come from the y prime. So when I plug the 9 into that one, I will get 1 over 2 times the square root of 9. So that'll be 1/6. So that's going to give me 1/6. So that tells me that m equals 1/6. Okay. So my slope is 1/6 at this point, and the point is 9,3. So I'm going to plug that into my point slope formula. Y minus y naught equals m times x minus x naught. So y minus 3 equals 1/6 times x minus 9. A little bit of work here. We'll distribute the 1/6, so we'll have 1/6x minus 9/6, which is 3/2. And then I want to get that 3 away from the y, so I'm going to add it to both sides, and if you make common denominator, we'll have y equals 1/6x plus 3/2. Now once again, let's go try and graph this. I'm going to pause it to make everything move a little bit smoother. So from everything we just had, I've got the graph here. The red line is the square root of x. That was our function. That's our curve. Let's just put that by itself for a moment. Okay, and then I've got the point 9,3 on the function. So then I'm going to graph the tangent line, which was 1/6x plus 3/2, and it butts right up against there. So we can almost see the slope of 3/2. I might have to zoom out a little bit. But from the slope of 3/2, I can see from that point going up 3 over 2. Excuse me, the slope is 1/6, up 1 over 6. So that works for the blue line. It's not quite for the red line, because remember the curve doesn't have the same slope everywhere. So as I move away from that point, the slope is no longer 1/6, but for the straight line it is. But we can kind of see it butting right up against there, and we can kind of see how it deviates as we move out. Alright, so that is finding the tangent line. Thank you.